All right, everybody, hello and welcome back. Today we're going to talk about graphing quadratic functions. Now, we have a couple different forms we're going to graph in, starting with standard, and then intercept, and then moving on to vertex. Now, each form has its own pros and cons, so we're going to talk about those along the way, which means some of the characteristics we are going to list out for each one might be a little bit different. All right, we're kind of just taking what we are given and doing our best to graph. So we take a look at this first one. We have y equals 2x squared minus 2x minus 4. So what we need to do is we need to graph 3 points and then the axes of symmetry. Now, one of those points has to be the vertex. So in standard form, to find our axes of symmetry, we use the equation x equals the opposite of b over 2 times a. Now, when we are in standard form, our b value in this case would be negative 2. So negative 2 is going to be a positive 2. Give myself a little more room here. So we have x equals positive 2 divided by 2 times my a value, which is also 2. So our x is going to be 1/2. So what that means is on 1/2 we have a vertical line that is going to be our axes of symmetry. Now that also tells us a little bit about our vertex. Since the vertex is on that axis of symmetry, we know the vertex is going to have an x value of 1/2. So if I know my x value, I should be able to plug into my original equation here in order to find the y value, or my output. So the y value will equal 2 times 1 over 2 squared minus 2 times 1 over 2 minus 4. So we get y equals 2 times 1/4 minus 1 minus 4. 2 times 1/4 is going to be 1/2. So 1/2 minus 1 will be negative 1/2, minus 4 will be negative 4.5. So we get a vertex value, it's going to be right about there. Now, the next thing we're going to do is we're going to find our y-intercept and its symmetric point. So what's important for us to remember is in standard form, there's a little trick we like to use to find that y-intercept, and it's always going to be our c value at the end. However, if we don't remember the trick, all we really have to do is know what a y-intercept is, and that is when x is 0. So if I take my equation, plug in 0 for x, we get y equals negative 4. So that is going to be my y-intercept, which is right there. Now, the symmetric point is a point we get when we take our y-intercept and reflect over our axes of symmetry. So we call it the axes of symmetry because either side, the left and the right, should be symmetrical to one another. So if we just take this point and flip it across, we will land right there, which is going to be our symmetric point, which I'll make a slightly different color. So our symmetric point is going to be 1, negative 4. All right, and just to explain where I got those coordinates from, if to go to our axes of symmetry is 1/2, we're going to go 1/2 on this side as well, which should take us to 1, and the y values will be the same. So now we actually do have all the information we need in order to graph. We've got our 3 points, the axes of symmetry, so I can go ahead and connect. Is my vertex a maximum or a minimum? Well, if we look at the graph here, we can see that our vertex is all the way down at the bottom. It is a lowest point, so therefore it is a minimum. Let's do this instead. It is a minimum. And then that minimum value, looks like my pen is no longer working here. All right, and we're back. So the pen now works, so we're good to go. So our vertex is a low point, so it is a minimum. the value of the function down there is that minimum value. So the y value is what we're talking about here. So our x value is our input. We're plugging it in. The value of the function, I should say, is our y value. So the minimum value is going to be y equals negative 4.5, which is the lowest output that we have. Now, as we can see, our function is concave up. And if we didn't know from our graph, we really are going to get that from our a value. When our a value is greater than 1, we are going to be concave up. That means it opens up. And when it is less than 0, it is going to be concave down. So greater than 0 means concave up. Less than 0 means concave down. Now, the domain of all quadratic functions is always going to be the same. Negative infinity to infinity. And my range we just get from the graph is the lowest point all the way up because we've got arrows. So we are going to have negative 4.5 up to infinity. Since we can never include infinity, it gets a parenthesis, but we do have an actual output of negative 4.5, so we put a square bracket. And that is how we are going to graph in standard form. Now, we can jump to our next form, which is intercept, and we call it that because it gives us our x-intercepts. By taking each one of these, each factor we call them, and setting it equal to 0, we get our two intercepts. So our x-intercepts here are negative 2, 0, and 1, 0. We've got 2 of our 3 points already. Axes of symmetry. Now, if we go back up here and we take a look, we know that the axis of symmetry should be right in between our points. It's directly between these two, should be directly between those ones. So the axis of symmetry needs to go through the middle. So all we have to do is find the middle of these 2 points. Now, it's a little bit difficult to tell in this case because we are not going to be exactly on a line, but what we can do to find the middle of something is we can add our 2 values together and divide by 2. So we'll end up with negative 2 plus 1 is negative 1 over 2. So negative 1/2 is our axes of symmetry. Now, just like before, if I have my axes of symmetry, all I have to do is plug back into my function to get the y value. So we're going to end up with y equals negative 1 times 1.5 times negative 1.5. Just to make sure I'm doing this right. We have 1.5 times 1.5. We are going to get a positive 2.25. So I'm going to switch colors here just to make this a little bit easier for us so we know exactly what we're looking at. Let's make it pink this time. So the vertex should be at positive 1, 2, and a fourth, which is right about there. And now we have all the information we need in order to graph. So I can connect these values. And this is what our function is going to look like. Now, we can continue with a few more characteristics. I can find my y-intercept just like we did before by plugging in 0. Now, I have 3 points, so I don't necessarily need it, but it might be helpful. So all I'm going to do is take my original equation, plug in 0, and solve. So again, understanding what a y-intercept is will make this process easier. Negative 1 times 2 times negative 1 should be positive 2, which is actually right about there. If we wanted to, again, we could reflect it over and get a symmetric point, which is right there. Okay? Now, Is our vertex a maximum or a minimum? As we can see, it is the highest value. So there's going to be a maximum, and again, it's the value of our function. So the max value is going to be the y value, which is 2.25. Concave up and concave down. Again, are we opening up or down? If we just look at the graph that we've made, we can see that it's concave down. But exactly as we did before, if we look at that a value, we could see that in this case, a is less than 0, so it is going to be concave down. Now again, our domain is always going to be negative infinity to infinity. The range we can get just by looking at our picture here. So we have the highest point all the way down. So the lowest we're going to go is negative infinity, and the highest is 2.25 with a square bracket. So there we have our intercept form. Again, it's a little bit different because we're given slightly different information, but much of the process is the same. Understanding each of our characteristics is going to be the key in us finding them. Okay? Now, the last thing we're going to do here is vertex form, so my equation's a little bit further off to the side than intended. But our equation is y equals a times x minus h squared plus k. So if we want to find the axes of symmetry, well, we call this vertex form because we are given the vertex. The vertex is actually going to be our h comma k values, which in this case we'll get from here and here. Now, if you notice in the original equation, we have a negative on the inside. Well, that negative turned to a positive. The only way that that works is if we are subtracting a negative. So the x value of our vertex is -2, and then the y value is -3. So -2, -3, it's right there. There's our vertex. Our axis of symmetry is going to go right through it, which means they share an x value. And we are well on our way. Now, one thing I do want to touch base on again is our equation in here is designed to have a negative x minus h, and then we just take the positive of h. Now, right here, because it is +2, most of us would want to take a +2, but remember, it's supposed to be a negative. So since the negative was switched to a positive, the only way that works is if we're subtracting a negative. So x minus -2 would turn to +2. Now our k value is exactly the same. If you think back to our previous units, everything that is a transformation of x is going to be the opposite. So it says +2, really it is a -2. Now if we want to find that y-intercept, again, it works the same way as before. We are going to plug in an x value of 0. We get y equals 2 squared is 4, 2, -1. So we will get a -1 right there as our y-intercept. Now, that symmetric point, again, we want to take it and reflect it over. We are 1, 2 to the right of our axis of symmetry, so 2 to the left will be that symmetric point, whose coordinates are going to be -4, -1. And now we've got all the information we need to graph. Is my vertex a maximum or a minimum? Well, as we can see, the vertex is a low point, so it is going to be a minimum, and the value of that is the value of our function. So we need the y value, which is -3. Concave up or down. Again, we can see from the picture that it is concave up. However, just like before, if we take a look at that a value, our a value is greater than 0, so concave up. Domain, once again, is always going to be the same for all quadratics. And then my range we get from our graph. We start with the lowest point all the way to the highest. So we have -3 comma infinity. Infinity always gets a parentheses, and because we have an actual point with a y value of -3, it gets a bracket. All right, so these are the 3 forms of quadratic functions that we are going to be graphing in this unit. If you notice, they are all different, and it does seem like a lot of information to remember. However, if you understand our characteristics, so such as how an axis of symmetry is related to the vertex, what a y-intercept is, and how to find its symmetric point, it should make all of these different processes easier. So please make sure we're focusing on the understanding of this unit, not the memorization, because this is, in fact, a lot of stuff, okay? As always, thank you for listening. If you have any questions or concerns, please feel free to reach out.